Okay, ladies and gentlemen, continuing on the same theme, we are still solving word problems. Today we're focusing on distance and money problems, and we are going to be writing and solving those equations. Don't forget to add in your homework score from last night. I believe we had 6 problems, right? Okay, so distance problems. So this is a comic strip from 1990. It says, okay, now listen up. Nobody gets in here without answering the following question. A train leaves Philadelphia at 1 p.m. It's traveling at 65 miles per hour. Another train leaves Denver at 4. Say, you need some paper? So this kind of problem here, a train problem, is so typical on tests like the SAT, the ACT, the Saber. These types of questions are like a test giver's dream question. So it's really important that you know how to attack them. So let's start with how to set up a table and using a table to help you organize your information. This one here is a money problem. It says part of the proceeds from a local talent show was $2,420 worth of $10 and $20 bills. If there were 37 more $20 bills than $10 bills, find the number of each denomination. So we've got the denomination, which is the type of bill. So we've got $10 bills and we've got $20 bills. Then they tell us information about how many bills we have. And we know that there are 37 more $20 bills than $10 bills. So let's let X equal the number of $10 bills. So this is going to be X here, the $10 number of bills. And we have 37 more $20 bills. Okay, so the value of those bills would be the denomination times the number of bills gives you the value. So that would be 10x. And again, times, this is going to be in parentheses here because we're going to multiply all of it. So it gives me 20 times x plus 37. Now the other thing that they have told us is this piece of information here, $2,420. So if I add up 10x and 20 times the quantity x plus 37, I should get the total 2,420. So 10x plus 20, x plus 37. So that's the equation that I'm going to write. Filling out a table is a great way to organize your information. So what we need to do is distribute. Now we get 10x plus 20x plus 20 times 37 is 740 equals 2,420. Combine like terms. That'll give me 30x plus 740 equals 2,420. Backwards through PEMDAS, subtracting 740 from both sides. I get 30x equals 2,420 minus 740, which is 1,680. Divide both sides by 30. And so I get x equals, divide by 30, 56. What does that tell me? Going back to what we defined our variable as, x is the number of $10 bills. That means there are 56 $10 bills. What was the question? Well, it says find the number of each denomination. So I've got the number of $10 bills. How many $20 bills were there? Well, remember there were 37 more than the number of $10. So 56 plus 37, there are 93 $20 bills. And we could check our math by doing 56 times 10 plus 93 times 20. Adding those two things together, we should get the total 2,420. That's just a quick check. Okay, let's try one more problem. So this is the train problem I'm talking to you about. Okay, it says a train leaves a train station at 1 p.m. It travels at an average rate of 72 miles per hour. A high-speed train leaves the same station an hour later. It travels at an average rate of 90 miles per hour. The second train follows the same route as the first train on a track parallel to the first. They're not going to like run into each other if one passes the other. They're next to each other but going in the same direction. In how many hours will the second train catch up with the first train? So what we've done here is we've set up a table that includes the important information. Anytime you have a problem like this, we call them distance problems. You're going to need the distance formula, which is distance equals rate times time. Okay? So this is a little bit more complex than just plugging in a rate and plugging in a time because we have two vehicles. That's why we need this table set up. So the first vehicle is just our normal train, and our second vehicle is the not fast, they used a different word there. They used high-speed train. Okay, then I'm going to fill in the other pieces of information that they gave me, the rate. So I've got 72 miles per hour for the normal train. I've got 90 miles per hour for the high-speed train. Time. They left at, sorry about that interruption. So we're talking about the time. So we've got that the train leaves the station at 1 p.m. So is that the amount of time that they're traveling? No. That's going to be extra information. Okay? So we've eliminated that extra information. How long are these trains traveling for? Well, we don't really know, because remember, look at the question. In how many hours? We don't know how long they're traveling for. What we do know is that the second train left an hour later. So that means the second train is going to be traveling for an hour less than the first train. Okay? So we don't know how long the trains are traveling for, but we do know that one left an hour later. All right, so again, same thing as the last problem we did with the money. To find the distance traveled, we're going to multiply rate times time. So 72 times x is 72x. And 90 times x minus 1 is 90x minus 90. I went ahead and did the distributing there because it was really easy distributing. Okay, now, how am I going to write my equation? They're traveling in the same direction, so their distances, how long will it take the second train to catch up with the first? Their distances should be equal. So the distance of this train should equal the distance of this train. So the equation I want to solve is 72x equals 90x minus 90. All right, so backwards through PEMDAS, I need all variables on one side. I'm going to subtract 90x. That will give me 72 minus 90 is negative 18x equals negative 90. Opposite of multiplication is division. Divide by negative 18. x equals 1. No, that doesn't make any sense. 90 divided by 18. I must have typed in my calculator wrong. X equals 5. Okay, so that means that the first train would be caught by the second train 5 hours later. But what's the question? In how many hours will the second train catch up with the first train? So 5 hours after the first train left, or 4 hours, subtract 1, 4 hours after second train left. Okay? Now, these problems can get complicated, but I think as long as you set up a table, you'll be able to get to an equation. What if this problem was talking about two trains traveling in opposite directions? They both leave the same station, and they go in opposite directions. And they want to know how long it'll take for the two trains to be 500 miles apart. Well, in that case, you would take the first train distance, 72x, plus the second train's distance, and it should equal 500 miles. And that would be the equation you would solve there. So you can see how they might be set up slightly different depending on what kind of information they give you. So homework tonight is My Math Lab. Just a few questions, give them a try, do your best.